Hello everyone, today's topic is tap changing transformers. Let us understand why tap changing transformers are useful. So tap changing transformers. You can see the diagram here. This is off circuit, as the name indicates, off circuit tap changing. Off circuit tap changing. Generally in the off circuit tap changing, the tappings are changed when the transformer is disconnected from the supply. Mean to say is this type of connection is useful when transformer is in off condition. That means the supply is off. So we can have the tappings as per the requirement and they can be taken out on the respective windings on the connections. Now when you observe here, there are different tappings when you can observe here. So here one winding has the tappings, so the other winding doesn't have any tappings here as per the diagram given here. Now when you see here, there are different tappings connected here. For example, tap 1, tap 2, tap 3, tap 4, tap 5, tap 6. Each tap is connected to respective windings here. Suppose the tap 1 which is connected to the winding here and the same is carried out to the switch there, to the respective switch, and they are brought out to the selector switches. Now by the operation of the selector switches, now you can change the selector switch and you will be able to select the respective tappings and you will be switching on the transformer for operation. So in this method, so as we it is very convenient as transformer is in off condition, but only disadvantage is each and every time the transformer need to be switched off in order to change the tapping switch. So one more tap connection we have is on load tap changer. This is called as on load tap changer. Now what is the difference between on load and off load? Let us understand here. Now by the diagram you can see here, here you have two different switches, selector switch 1 and selector switch 2, as well as there is a diverter switch here. This is called as diverter and two selector switches. So this is the line consisting of your different windings connections. Now under the load condition, that is when the transformer is on operating, on load, that is transformer is operating, it is not switched off, it is operating in nature. Now here under load conditions, we have to we need to, it is required to maintain the voltage on the secondary side of the transformer with a certain arrangement when this transformer is connected to a system without making the load off. That means here the transformer is operating, you need not switch off the same. So that's why the name is on load tap changing. Now you can see from the diagram, as we mentioned, there are two tapping switches, that is selector switch 1 and 2, which are provided in taps 1 and 2 respectively. So there is a diverter switch which is connected to tap 1, you can see here the diverter switch which is connected to tap 1 and to the neutral terminal here. You can, that can be seen here from the diagram. Now there is a procedure here to change the tap from one position to other position. Let us understand this procedure step by step. First, when you see here, there is a resistance R1, you can observe here, is short circuited to the contacts A and B. When you observe here, the A and B, and it is closed. Now the load current which flows through the contact A initially, so this is the load current, it flows through initially A from tap. So this is the tap, from here it flows through A. So this condition we call as nothing but running position at tap 1. We call this as running position at tap 1. Now with the help of the external operating mechanism, the diverter switch, which is diverter switch, this is the diverter switch. So here this is the diverter switch. This diverter switch we call as external operating mechanism. With the help of external mechanism operator, the diverter switch is moved to open the contact A, that is contact A is open now, and the load current will flow through R1 resistor R1. Now here through the resistor R1 and it flows through contact P. Now as it is simple that through the A is open now, it will flow through the R1 and reaches the point B. Now once it does that, then the other side, you can see here, observe the contact C closes, and once the contact C closes, your resistance R1 opens up. So when the moving contact of the diverter switch continues, so it has moved from the right to left side. Now the resistances R1 and R2 are which are connected across the taps 1 and 2 respectively, so that the load current flows through resistances to midpoint of junction B and C. So this is the junction B and C. Now with further movement, what happens now, the diverter switch will move to the left, making the contact B to open, and the load current flows to tap 2 through resistance R2 and contact C. Now at last, the diverter switch moves to the extreme left position. This is the diverter switch which moves to the extreme left position this side and closes the contact T. So this will short circuit the resistance R2, and the load current will flow through the tap 2. So from tap 1 we have changed to tap 2 through the contact T, which is in the running position. Now what happens, the selector switches are used in order to change the different tappings here. Now that the selector switcher is selected for tap 2, the same thing can be shifted to 4 here, the same thing can be shifted to 3, and the remaining procedure of changing the tappings will remain same. So this is all about on load and off load tap changers. Thank you.